Okay, so we saw last week how to get volume, right, of shapes. We talk about volume of prisms, we talk about volumes of pyramids, cones, spheres, things like that. But what if I wanted to get the volume of a screw? Or you guys can see it here. Well, you can cut it down as a cylinder, and then there's a prism, or what most people do, they have a place here with water. So I just want you to focus just on this image. So we have a little thing with water. And let's just say there's some measurements. We cannot see the measurements there, but let's say the height of the water is 100 milliliters. So we have it at 100. And then I have a screw on the outside. But then I grab this screw, put it in the water, so it looks like this, and then the label, the water goes up to 150 milliliters. Notice on the left, the water is by itself at 100, but the screws on the outside. On the picture on the right is the water with the screw. So the way I'm going to find out in milliliters the volume of the water, I mean the volume of the screw, I'm just going to subtract the two levels of water. I'm going to go 150 minus 100, and it's going to tell me this is 50 milliliters. Now, liters is it's a measurement that we use for liquids, right? In the English system, we use gallons. In the metric system, we use liters. When they talk about length, we use inches in the English system and meters for the metric system. So to measure water, it's either liters or gallons, depending on the system you're using. When you're comparing length, we use meters or inches. Now, when we compare weight, it's either grams or pounds. Okay, so liters is basically we're measuring everything in liquid. Looking at here, my example number 20, if you notice, I start with a liquid here, and let's say, if we cannot see it that well, but let's say the measurement of the water by itself goes up to 50, and then there's a key on the outside. But then, let's say here, the water goes up to 60 once I put the key on the inside. So obviously the volume of the key is going to be the difference of those two numbers, 60 minus 50. So now I'll say, well, my key is 10 milliliters, right? So it's easy to do. And believe me, this is what people do, scientists, when they're measuring volume of stuff, they usually use water. Notice if you guys look at I don't know, liquids to clean pools or something, you guys can go in and say, all right, there's liquid, there's powder, that is measured in liters. You're like, well, how's powder measured in liquid? Because somebody measured it this way before, right? They put the powder inside the liquid, and they saw how much did it change. So that's how we can measure it in liquid. And like I said, this method is used a lot. We call this method of displacement. Displacement means the place changes, right? The place, the value of the water changes. But another thing I can do, if I want it in cubic inches, let's say I have a fish tank. I'm looking at question number 21, and I put in a figure. You guys see a Y figure that I put in on my fish tank. My fish tank is the base is 35 by 12 inches. You guys see the base is 35 by 12, but let me highlight here. You guys can imagine, you guys can see, right? You guys can see that it will give me a base, a 35 by 12 base. But now here on the side, I saw that once I put the figure, the white figure, whatever that is, it changed 1.3 inches. So you can do this on a fish tank. Just be careful you do actually do it. Be careful what you put in there. Don't contaminate your water for fishes. But you can see what's the height that it changed in your fish tank, and then times the base. Now here, if I wanted to find the volume in cubic inches of this figure, I just remembered the volume. Last week, we talked about prisms. It was the area of the base times the height. So in this case, the base is a rectangle, 35 inches times 12 inches. That's the base. In the height, right? How much height did it change? 1.3 inches. Interesting is that I have inches times inches times inches. So wouldn't that give me inches to the third, right? Inches times inches times inches. That's the reason why we call this cubic inches. Now the other numbers, I'm just going to multiply it. 35 times 12 times 1.3, and it will give me 546. So whatever that figure is, not measured to scale, so don't think that it's really measured to scale. That measure, the volume of that figure is 546 cubic inches. Same thing for number 22, right? We can imagine I have a base here. It's a 13.4 by 6.2. You guys see that? And the height difference is 2.1. So that fish, again, is not measured to scale. If I wanted to know how much, what's the volume of that fish, I'm going to do area of the base times the height. So I will go 13.4 inches times 6.2 inches. That's the area of the base. The height is 2.1 inches. I know inches is all to the third, and I just have to go 13.4 times 6.2 times 2.1, and it will give me 174.468 cubic inches. Again, I just wanted to cover this just to show you how you can get the volume of figures that have odd looking shapes. Just use by displacement, because this is used a lot. Now your homework is not going to be on displacement. Your homework, what we're going to be looking at today, is composite figures. All right, so let me move this real quick. Like I said, I just wanted to cover that so you guys know how to get volumes of odd looking shapes. But what I'm going to be doing on the homework is, imagine I have a figure. Let's do this figure. Let's do here. And then it even shows you as and I'm gonna give you some measurements. All right, you guys are gonna be looking at this figure, and it's gonna give you some measurements. Let's just say I do that, and then I'll even point out that here in the center, there's a 90-degree angle, and let me call that measurement 6. And boom, I ask you, what's the volume of that figure? In reality, the way I want you guys to work this out, I want you guys to notice that on the top of this figure, there is a pyramid. And at the bottom of this figure, there is a prism. Okay, so we learned, like 2 weeks ago, we learned, or last week, we talked about volume, right? We talked about the volume of prisms was going to be the area of the base times the height. And we said the pyramids, the volume was going to be the area of the base times the height divided by 3. I want you to see it as two different figures. Okay, so for the pyramid, we can say this is 5, this is 4, and then the height is 6. So I'm just going to go, the area of the base is 5 times 4. Because of the base, you see it is a rectangle. The height is 6. and divide this by 3. So just the pyramid, 5 times 4 times 6 divided by 3, it gives me that just the pyramid is 40. Just the pyramid. Now the prism at the bottom, this is 5, this is 4, this is 3, right? The base is 5 times 4, because the base looks like a rectangle. The height is 3. So just the prism, 5 times 4 times 3 is 60. So just the pyramid is 40, just the prism is 60, combined will give me 100. For today, we're going to be looking at composite figures. So I'm going to be putting 2 figures together. Make sure you guys know how to get the area of prisms, the area of pyramids, the area of sphere, volume of spheres, volumes of everything, cones. One figure that might give you a little bit of trouble. Let me show you guys an example. It's, well, cones shouldn't give you a little bit of trouble. The problem will be when I fill the top with we call this hemisphere, which is basically half of a sphere. Remember, for the cone, we just go the area of the base times height divided by 3. The base is a circle. The height obviously will be given, and then 3. So that's not that bad. Now for the top, a hemisphere, like the half of a sphere, remember the volume of a sphere, we talked about this already. It was 4 times radius cubed times pi divided by 3. Remember, that was a whole sphere. So I'm going to say for the hemisphere, let me multiply this by half. So let me multiply this by 1/2. So it will give me 4 times radius cubed times pi over 6. So if you guys run into hemispheres, right, half of the sphere, make sure you guys do that. So the way I will do that, I don't have the measurements here, but what I will do is I will get the area of a cone. I will get the volume of the cone. I will get the volume of the hemisphere and then just add them up. So this is what we're going to be practicing for today.